All right. So a single replacement reaction. You have one partner switching places with a single person. A double replacement reaction then is if you have two couples and they swap partners. Okay, so I have Joe and Mary, and I have Josh and Sue. Sue is more attracted to Joe, and Mary's more attracted to Josh, so they switch partners. That's a double replacement reaction. So how do I identify this reaction? You could say the cations switch places, or you could say the anions switch places. All right. Either way, the substances are swapping partners. Okay. So the general form of this reaction is I have RS and TU, generic metals and nonmetals. The R switches places with the T, so now I have R and U and T and S. The metals switch places, or you could say the nonmetals switch places. But I still have a metal and a nonmetal, and a metal and a nonmetal. Now this is typically going to be two ionic compounds switch partners. So here are what my letters would represent in my generic equation. Most of the time in these double replacement reactions is when a precipitate will form. And that's going to be what we're going to be looking for, is whether or not a precipitate or solid has formed. So take a moment, jot down the general form of the reaction, the definition of the reaction, and here is the example we're going to look at. We'll look at it in class, so you can make this prediction if you'd like, and next class we can make observations before and after. So this is finishing up with page 3. Once you're done with this, go ahead and turn to page 4. We'll talk a bit about the solubility rules and then finish up with our fifth and final type of reaction, a combustion reaction. All right, so to predict whether or not a solid is formed, we're going to look at these solubility rules, and we'll focus on these more next class. But these solubility rules allow us to determine if a solid has formed. So I look right here, PbI2, I look for a rule that applies to that compound. I find right here halide ions, including I, are soluble in water, meaning they are aqueous, except with lead is insoluble, meaning it's solid. And nitrate is soluble in water, and that's why KNO3 is aqueous. I'll explain this more in class, and we'll take some time to practice this. For now, I just want you to understand the basic definition of a double replacement reaction. Okay? All right. Combustion. Our final type of reaction, combustion. Hopefully you have already heard the word combustion and you think of things burning. It is exactly that. It is when oxygen combines with another compound to form water and carbon dioxide, often producing heat and light. So here I have methane react with oxygen to produce carbon dioxide and water. This again generates heat and light. So take a moment, write down this definition of a combustion reaction, and then we're going to work on that homework, 5.4, balancing each type of reaction. Be aware these combustion reactions can be a bit tricky when balancing, but remember when you get to oxygen and it won't balance, double your coefficients, start over, and balance. Okay? So what your homework again is going to be is worksheet 5.4. You're balancing each type of reaction. You're writing a description as to what each type of reaction, or definition describing each type of reaction. And we will have a quiz and a homework check next class on 5.1, 5.2, 5.2b, 5.3, and now 5.4. So again, please have all of those worksheets done for next class and be ready for the quiz.